What's up, guys? Tip number 2, getting this video recorded. Ended up, last video, computer crashed halfway through, so let's try it again. But we are here in quadratics. We're scrolling down, so we've already covered a lot of this stuff. We're going to go into the quadratic formula, okay? So before we even start, let's talk about a few things. I'm going to give you the quadratic formula in a minute and show you how to apply it. I would watch this video and this one and go through this article. Article especially because it's going to show you some different things about the quadratic formula, why it is what it is. Remember, this is the standard form of a polynomial. That's the first thing to remember in the quadratic formula. There it is. It's a long formula, okay? And I'm going to tell you now, you probably need to memorize it. It's useful. Factoring, solving quadratics by factoring is easily my preferred method to solve a quadratic. Hold on, let's take that back. First, I would rather solve a quadratic by square roots if possible, but those are very few and select cases, so that doesn't always happen. So the next thing that usually happens is this, or factoring. Factoring's next, so square roots and then factoring. If factoring doesn't work, and factoring will not always work, I use this formula. You can complete the square. If I need vertex form, I'll complete the square because I hope you noticed in the last problems, completing the square puts it in vertex form. And I'm going to go over some problems later. Hopefully that will help with that. But quadratic formula, it works every time, all the time. You need to probably just memorize it. So memorize the formula. This goes through some worked examples of that. I'm just going to go ahead and pick up. I'm going to go start a practice problem. So let's just go here. And here we are. So let's just go ahead and start working. So first things first, quadratic formula is, where's my thing at? Oh, here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, before you can use this formula, you got to make sure that the equation or the polynomial is set equal to 0. And right now it's not. We need to add 8 to both sides. So add 8, so you have negative 7x squared plus 7x plus 9 equals 0. So there is our standard form of this quadratic. There's A, there's B, and there's C. So we literally just plug it into the formula. The hardest thing about this way to solve it is literally the formula. So here we go. So negative b is positive 7, so it's negative 7 plus or minus the square root of b squared, which is 7 squared, minus 4 times a, which happens to be negative 7, times c, which is 9. All over 2 times a, which is negative 7, okay? So we have negative 7 plus or minus. We need to simplify this in here. We have 49 plus, and it's plus because 2 negatives. We have 2 negatives, one here, and 2 negatives make the positive. So 4 times 7 times 9 is 252. All over 2 times negative 7 is negative 14. So we're going to go back up here to keep working it. So this is negative 7 plus or minus the square root of 49 and 52 make 301 all over negative 14. So notice A is our answer. Now, before we go on, we're going to talk real quickly about that piece there. If you can take the square root, you need to. And then you may get answers like B. So just because it matches it doesn't mean it's the answer. 301 is, I believe, a prime number. I'm thinking it's probably a prime number. 7 may go into it. I don't know, actually. No, 7 does not go into it. Oh, it may be a prime number then. Good. So, but I know the square root of 301 is not a square number, so that is our answer. So let's answer it. Let's go ahead and do another one. So let's do this one together. And And we'll get ready to move on after that. So again, in order to apply the formula, you got to make sure that one side, we need this to be a 0, the right side to be a 0. So let's add 6x squared to the other side. So now, when we add the 6x's together, we get 0 equals, and I'm going to rewrite this in standard form. So negative 9x squared plus 6x squared is negative 3x squared plus 4x plus 10. So again, that is C, that's a 0. That's B, and that is A. So x equals negative b plus or minus the square root of b squared minus, not plus, minus 4ac all over 2a. So that is equal to, negative b is negative 4, so negative 4 plus or minus the square root of b squared is 16, minus 4 times a, which happens to be negative 3, times c, which is 10, all over 2 times negative 3. Okay, so again, this is just plugging in, plug and chug is all this is. We have negative 4 plus or minus the square root of 16 plus, because 2 negatives make a positive, that's 120 all over negative 6, which is equal to negative 4 plus or minus the square root of, what is that, 136 all over negative 6. Okay, and so you may be looking at this and going, okay, Coach, the answer's not showing up. What's the problem? And I also know, Coach, that this is not a square number. Well, go back and watch videos on simplifying square roots, okay? It's something that you're going to need here, okay? So when you simplify square roots, we talked about this a little bit a couple months ago, actually. You're pulling square numbers out, okay? So I know for sure 4 can divide into 136. So 136 is the same thing as 4 times, I have no idea. 136 divided by 4. Oh, well, I can just get that out of the way there. 34. So 4 times 34, which is the square root of 4 times the square root of 34. Well, the square root of 4 is just 2. So this is 2 root 34, okay? So now let's rewrite this up top. We have equals negative 4 plus or minus 2 root 34 all over negative 6. And it still doesn't equal this. And the reason why is, I want you to notice, let's just do this. This will be easier. That number, so negative 4, 2, and 6, they're all even. Technically, you can cancel out common factors here. So one way to easily look at this a little easier is if you pulled a 2 out from both of those. So if you pulled a 2 out, so 2 in the front, you got negative 2 plus or minus the square root of 34. And the reason why it looks like this is because, again, when you pull this 2 out here, when you pull this 2 out, 2 goes into 2 one time, leaving a 1 in front of the square root here. Let me use my mouse here. Leaving a 1 in front of the square root. However, because 1's in front of it, we can drop it, so it's okay. All over negative 6. But now you can cancel out common factors. So if you remember before, weeks ago, I said you can only cancel out factors with factors. You cannot cancel out parts with the whole. Only wholes and wholes can cancel each other out, okay? Well, this is a whole factor. This is a whole factor. So 2 can go into 2 one time. 2 goes into 6 3 times, leaving negative 2 plus or minus the square root of 34 all over negative 3. There's our answer, okay? So, a little tricky, but you should be able to do that. So, don't click that. Let's see, click here. Again, guys, it's so vital. Like, I don't know, I'm not there, sorry. You're going to need to watch some of these examples so you can see what he's doing, okay? I'm telling you, you need to do it, okay? So let's talk about the numbers of solutions. So now the numbers of solutions is related to the number inside of the radical symbol here, okay? So the discriminant is part of the quadratic formula under the square root. It was actually found hundreds of years ago. If the discriminant can be positive, 0, or negative. So, and this determines how many solutions there are in a given equation. So let's talk about how it does that real quickly before we move on. So how does it determine it? Well, I want you to, oh, good night. What in the world has happened here? I'm not exactly sure what happened there. Come here. That was weird. Okay, so if you think about the discriminant, it's inside this parenthesis, or inside the radical symbol. So b squared minus 4ac. Well, if it's positive, okay, so the square root of a positive, you have two roots, right? Two roots. Okay? The square root of 0 is just one root. And then the square root of a negative, well, that's impossible, so you have no roots. So the discriminant tells you how many solutions you have. If you have a positive discriminant, like we have in the last two problems that we've worked, then you're going to have two possible answers. Okay, and that's why the plus or minus. So remember, right here, the plus or minus, this causes there to be two answers. Now, if your discriminant equals 0, like in this case here, then you're only going to have one answer. And the reason why is you're going to get negative b plus or minus the square root of 0 all over 2a, which the square root of 0 is just 0. And plus or minus 0 doesn't change anything, so negative b over 2a. That's it. So you have only one solution, and that's what happens to be your solution. And then finally, if the discriminant is negative, you don't have any solutions. Now, that doesn't mean it's not a graph. What that means is if you don't have any solutions, you have no zeros. So if the discriminant is negative, that means it never crosses the x-axis. So it could look like that, it could look like that, it could look like that. It just never touches the x-axis. So that's the key thing to remember there, okay? So let's go and work a couple problems now. So this ain't too bad. This is actually easier in my opinion than the other one. So we have the problem. It says, what is the value of the discriminant of f and how many x-intercepts does the graph of f have? So again, we talked about how to understand that. So the discriminant, again, is b squared minus 4ac. Well, if we look, there's a, there's b, and there's c. So let's plug it in. So b squared is 12 squared minus 4 times a, which is negative 4, times c, which is negative 9. So I like to take care of my signs first. Negative times a negative, negative times a negative is a positive, times a negative is another negative. So I know I have a minus sign in between. So that's 144 minus a number, okay? So 144 minus 4 times 4 times 9. Okay? Well, that happens to be 144. So what's 144 minus 144? 0. So what are the implications of the discriminant being 0? That means it crosses it. Again, the square root of 0 is equal to 0, so plus or minus 0 is just equal to 0. There's only one solution. There's only one time it's going to cross that x-axis. So it's going to look something like this. It's going to touch it one time and go back up, like that. Or like that, okay? So it just touches it once. So what is the value of the discriminant? It's 0. Not 6, but 0. How many x-intercepts does the graph of f have? 1, because it only has one 0. Okay? Again, 0, remember, 0 of a graph is the x-intercept. Okay? So, 0, 1. Let's do another one. Oh, even better. This one's easy. Oh, man, guys, this problem's easy. We don't even have to determine the discriminant. It's asking, is the discriminant of g positive, 0, or negative? Well, in order to determine if it's positive, 0, or negative, we need to find out how many zeros do we have. To figure out how many zeros we have, how many times does it cross the x-axis? None. It doesn't cross it. It's right there as close as it gets, and it doesn't get there. That means there's no solutions, no zeros. Well, that means it's negative, because you cannot take the square root of a negative, okay? Go back to earlier in the video when I showed you square root of positive, square root of 0, and square root of a negative, okay? Let's do one more before I go on. I think one more and then this video is going to be done, so. All right, here we go. Whatever, I'm going to leave it there. I don't care. So we have A, B, and C. So b squared minus 4ac is equal to b squared is 10 squared minus 4 times a, which is 6, times c, which is negative 1. Well, 10 squared is 100. 2 negatives make a positive. 4 times 6 times 1 is 24. This is 124. So now it's 124. We can take the square root of 124, and we'll get two different answers. So what's the value of the discriminant? What's 124? So how many real number zeros does f have, or how many x-intercepts? It has 2. It's going to dip like that, okay? Yep, like that, especially because it's positive a, so I know it opens up. So here we go, 124, 2. Okay, so go back, watch some of the videos of his, or rewatch mine, and hopefully that helps clear up some things on the quadratic formula and the discriminant.